All right, clicking the button. And we have a 30-second delay, so that's good to know. I'm just going to switch to my camera view. There we go. It's going to be fun. All right. Wait, we are still missing another speaker.
He has a session after yours, so I think it will be fine.
His session
Perfect.
is by around 4:30. That's like in another half an hour.
Perfect. Then I think we're ready.
Yep.
The fun thing is, even this is already on the YouTube screen.
Okay.
Yeah, I think it's just
We have a 30-second delay, so that's good to know. I'm just going to switch to my camera view. All right.
Yeah, live. Yeah, live.
There we go. One of you probably has the YouTube stream running in the background. Wait, it can be confusing. Another speaker.
I muted that. He has a session after yours, so I think it will be fine.
His session is by around 4:30. That's like in another half an hour.
Right. Perfect. Then I think we're ready.
Yep.
The fun thing is, even this is already on the YouTube screen. I'm just.
Yeah, I think it's just
We have a 30-second delay, so that's good to know. There we go.
Yeah, live. Yeah, live.
All right. Kick it off whenever you're ready. One of you probably has the YouTube stream running in the background. Wait, it can be confusing. Another speaker.
I muted that. He has a session after yours, so I think it will be fine. Hello, everyone.
His session is by around
So, thanks for
4:30.
joining.
That's like in another half an hour.
Perfect.
This is going to be an exciting
Then I
session.
think we're ready.
We have Kerim
Yep.
from HashiCorp. He's a developer advocate over there, and he does some amazing stuff. So I'll just hand it to him and let him take over. And you can learn Terraform today. Just glad that we're going to be learning something exciting today. So let's start.
Awesome. Thank you for the intro. Let me just switch off the pictures here. Oh, sorry, not this one, obviously, but let me switch to Keynote. And then I think we're ready. So just quick tech check. You're able to see the intro slide, right?
Yes.
Awesome. Cool. And let's kick it off. So we're going to be talking about Terraform today, which is, if you ask me, it's one of the most exciting tools that has happened to infrastructure in the past 5 to 10 years. And so let's start with the basics. So good afternoon, everyone. And thank you for joining today's session. Super exciting to be hosting this. It's actually my first session as developer advocate for HashiCorp. So I'm excited to be kicking this off with you. I think we're ready to start. So my name is Kerim Satirli. I've been working in IT operations and automation for the past decade. And I'm a fan of complex systems that work well. And I especially like the challenge of getting there, building a system that really works. So let's see. Like Avilash said, I'm a developer advocate at HashiCorp. My main focus is Terraform. And last but not least, like some of you, I'm also one of the organizers of a HashiCorp user group. If you have any questions after the presentation, or just want to talk about Asian whiskey or chocolate cakes, things I like, you can find me as K Satirli on GitHub, Twitter, Keybase, and pretty much everywhere. So before we get started, I really want to talk about some of the basics. Today's session, or actually both sessions, we'll be talking about infrastructure in the IT sense. So servers and the applications we run on them, the configuration that's needed, and any associated resources. More specifically, we'll be talking about approaching infrastructure from a code perspective. So simply put, infrastructure as code, or IAC if you're lazy, and you really should be because it's a long word to type, is the process of managing and provisioning resources with machine-readable definition files, as opposed to manually configuring resources in a UI. So when we talk about resources, we talk about virtual machines, security groups, network interfaces, software-defined storage, but this can be a lot, as you'll see. So the easiest way to think of it is as executable documentation. You have code that you can look at, you can read it, it's documented, but you can execute it. So human readable, but applications like Terraform, CloudFormation, Ansible can execute it. And IAC, so infrastructure as code, is an enabler for many good things. It provides a codified workflow. So you can commit your work, you can version it. And then because it's code, everything you love about version control applies here too. You can collaborate with other engineers, or you can roll a change back, which, sometimes that happens. You can roll forward. You can easily spin up an additional set of resources, which can be super useful if you want to have a traditional development, testing, acceptance, and production environment. But most importantly, because everything is written out, you can spin up these resources in a safe and predictable way. So infrastructure as code is, I think, is pretty cool. And with that common understanding, let's have a look at what we'll be talking about today. So first up, I want to share a few of the concepts behind Terraform. This, I think, is knowledge that will help you along your journey as a practitioner and is great for AWS, but it also will be applicable when you work with other providers. Then we'll be provisioning our first resources inside Docker, inside AWS, and we'll look at how we can connect multiple items together. And finally, we'll be talking about some of the more advanced use cases and learning resources. The stuff I wish was available 5 years ago when I started using Terraform. Things really have changed, and they have changed for the better and have gotten a lot more exciting. And if you have questions, just drop them in the YouTube chat. I think Avilash and Harsh are both looking at that and collecting them, and I'll get to them as soon as I'm done here. So I've structured today's session in a way that we'll be looking at code and I'll be explaining it. And I think I saw that question come up on the YouTube chat. We don't need to actually type anything yourself, because realistically, I've already typed it. I'll share the code samples with you, and I'll share those in a repository so you can clone it, you can fork it, you can do whatever you want with it, but you don't need to type things from a YouTube stream because that's silly. So Terraform is an infrastructure as code application that enables operators, so folks like you and me, to create and maintain infrastructure components predictably. And to do so, Terraform uses a system called providers, and those support a wide range of external services. Excuse me. These things always happen on live stream. And I think Kino just decided to fall away. So back to Terraform. Provider is responsible for understanding API interactions and exposing resources. And that sounds a little bit abstract, so we'll look at that in a little bit. Terraform has approximately 125 official providers that HashiCorp maintains either on our own or with our partners. These range from AWS to GCP, Azure, Docker, New Relic, Datadog, so many more. It's truly amazing what you can do with Terraform. And it's very easy to build your own provider. And then there are roughly 175 community maintained providers for services such as AgileBit's 1Password, the Stripe payment processor, Jira, and even the unified networking hardware. You know, those Wi-Fi routers and everything that you get. We had one of our employees write a Terraform provider for that, because that's how useful Terraform can be. So the Terraform application itself is platform agnostic, meaning you can use it on macOS, on Linux, on Windows, or even in your browser if you use Terraform Cloud. Though having it local is really a lot easier when you're just getting started. So in today's session, I'd like to show you how to use the AWS provider to manage your infrastructure in your AWS account. But before we can do that, I want to show you the basics of Terraform. So when you write code for Terraform, you do that using a language called HCL. And HCL is the HashiCorp configuration language. It's a common language supported by all our tools. And learning HCL is really a huge investment in an ecosystem that can take you from a single machine or a single resource even to a full service microarchitecture spanning multiple continents, several different cloud providers, and something that caters to a variety of use cases. So let's have a look at what HCL looks like. In this example, we have a resource called service, and this resource has a single key value item. This is purely for simplicity though, because the service item could and realistically would have many, many more key values that define various attributes. So let me show you a more evolved example with a named service. We'll use the HTTP service, and in there we have a resource that we name proxy, or web proxy actually. And we'll add a key value to define the listen address. And then we'll add another object. In this case, we're defining the process we're proxying, and we're giving a command that gets run with an argument to make sure the proxy app starts up in a server mode. And this is just a fictitious application, though I'm sure somebody has built an app called proxy app. This is just to show you how simple it really should be. So if you look at the screen, you can see that HCL is both human readable and machine readable. It's JSON compatible, so you could write all your HCL in JSON, but realistically, JSON is a little bit harder to read compared to traditional HCL. And you really don't need to, because HCL is supported by all major code editors and IDEs. This syntax is, I think, something you can pick up in a few hours and use with real resources. And that's a huge thing. If you remember your, let's call it the out-of-box experience with, I don't know, Java, even a hello world is already a lot more complicated than this. Now, let's say you're writing a lot of this code to use some kind of template structure, right? So you would like to have something like variables, so you don't repeat yourself over and over, and more importantly, you don't want to have to hard code everything. For those cases, yep, you can use the variable syntax. So let's go ahead and define a variable. We'll call this one port, because we're defining a port, in this case for the web proxy, and we'll give it a default value of 8080, which if you look up for the service, those are the same values. Personally, I always like to add a description to every variable. because it allows me to understand what the variable does. Right now, port, super simple, right? 6 months down the road, port, still very clear. Now imagine you're defining something like a security group ID. 6 months down the road, are you still going to remember what the ID that ends in 125 was actually for? I generally don't. So having a little bit of description makes my code more of a documentation. Everyone wins. So next, we'll update the web proxy resource and change the listen address from the hard-coded value to a dynamic one. We do this by adding a bit of code, and presto, your listen address now contains a value that is dynamic and will change whenever I update the value in the variable. So at the bottom where it says 8080, if I change that to 8081 and run a Terraform apply, the web proxy resource would also see that update. So if you're looking at the code, you can see that I define the service first and the variable second. In some languages, this would be a problem because of resource dependencies. In HCL, this order doesn't really matter because the code graph or the resource graph gets rendered before any actions take place. So the listen address you see at the top, which refers to a variable at the bottom, is only filled in dynamically after the variable has been rendered. Of course, for single file structures, it still makes sense to define things in a logical order, the way our brain processes them, which usually is top to bottom. But as you get into much larger setups with Terraform, you'll end up having situations where your variables live in one file, your resources live in another, and then having them structured in a way that makes sense to you is much better. And let's just have Terraform figure out the order. Whew. That was a solid amount of theory. And when we were talking about this, we were all internally thinking, yeah, this is a lot of theory, but I promise you this will be useful for the next part. Let's have a look at how we get this into Terraform. We'll start with the code editor, new file. I think Abhilash briefly mentioned an interest in Docker. So let's start by defining a provider first. And for that, we're going to use the Docker provider, which is one of our most simplest providers to start with. It has, I believe, 4 or 5 resources. It's a great first step because it keeps the complexity low in a way. When you're learning something new, learning to walk is a lot easier if you learn how to crawl first. So in Terraform, you define providers with a named block that identifies the provider type. In our case, this is Docker. And whenever you set up a provider, you really should set a version string. Terraform doesn't force you to, but if you do it, you pin your resources to that specific provider version or range of versions. Version pinning virtually guarantees that my code will keep working, even when the Terraform provider changes upstream. So let's say the Docker provider gets a release for 3.0, that would not be covered. But I don't have to worry because I pinned this to 2.7, and that means my code will just keep working. So it makes it easier for future maintainers of this code base to understand which version of the provider documentation is applicable as new features get added down the road. So next, we set up the host for the Docker provider. I'm going to set this to my local host so I can test things out easily and quickly. But you can also set this to a Unix socket, and Terraform will work just fine. You could set it to I believe an SSH tunnel. There's a couple of different options. And in the code I'll be sharing with you later, I've included code samples that showcase these different types of scenarios. And so finally, I'll add a block for registry authorization, because that allows me to download private images from my Docker registry through Terraform. Well, not my Docker registry, but any Docker registry I specify in there. So our provider is configured, and now it's time to switch to our terminal. And we'll be switching between code editor and terminal a little bit. I've generally made that clear in the slides. Terminals usually have a black background. Code editors have a dark gray background. I really hope that works out on YouTube. If not, we'll fix that somehow. But in regards of terminal, when you start playing with this, I just use the built-in macOS terminal, but this will work just as well with iTerm or PuTTY or any other terminal emulator that you have available. I think we even had a colleague once SSH into their machine from their cell phone, their smartphone, and run Terraform that way. Not the first use case, because Terraform's output is usually a lot of letters and small screens don't work for that, but it's possible. So in our terminal, to set up our provider or providers, you can use the init command. Think of this as the git init of Terraform. It's a helper command that sets up your local directory with the right binaries for all the providers you configured. In our case, that's just the Docker provider, which you can see about half of the screen. But as you expand your Terraform code base, you'll likely end up having multiple providers. For example, if you work with GCP, a lot of the newest resources are behind the beta provider. So you might have that one, and you have the normal GCP provider. It might be that you're testing specific AWS features that require an additional provider, or you might be doing something that requires random code generation. So we have a provider for that as well. And so after running Terraform init, and if we now inspect our local file system, there'll be a new hidden directory named .terraform. So I use a tree command in my terminal to see what's in there. And we can see that Terraform downloaded the 2.7.0 version of the Docker provider, which is exactly what we instructed it to do. And as I'm on macOS, the provider ended up in a directory called Darwin AMD 64, which reflects my operating system and the CPU architecture. So back to our editor, and let's add a resource for Docker image, because realistically, we've done the init, we've got the provider, but we haven't done actually anything with resources. So I'll name this resource Hello World, and the resource is of type Docker image, and we'll pull the latest version of the image for now. And I should probably say that latest works really great if you're testing things, but it's the worst version tag to use because it doesn't really tell you anything about what you're using. Now, if you remember from before, we said we didn't want to hard code things. So let's go ahead and turn latest into a variable. For simplicity, I'll name the variable image version, but you should be able to give it any name you want as long as you keep it descriptive. You could say, why don't we call it version? Wouldn't that be super simple? And yes, it would. But as you will learn, Terraform helps you write better code. So Terraform actually informs you that version is not a variable name you can use because of its very specific meaning. So version, not the most descriptive word. Image version, also not super descriptive, but at least it's not a forbidden one. And so we can use that for now. So next, I'll add a type for my variable. We haven't done this before, but we're doing it now because types help us define what kind of data a variable should expect. In the case of an image version, can be a string or a number. But in terms of generic variables, you can have strings, numbers, booleans, more complex types, such as lists and sets and maps. And then if you really want to get fancy, you can define lists where we also define the types of the children. So for example, if you have a list of strings or a list of booleans, same for sets, same for maps. What we're doing with this is we introduced a few versions ago the ability to typecast specific variables. And the next step will be to have full validation of your variables in there. So you could say image version has to be a string and it cannot be the word latest. And I think that's currently available with Terraform 0.12, 2021, something like that. It's a beta feature, but it's super useful because let's say we're specifying that image version cannot be latest, and somebody does put latest in there on a Terraform plan run. Terraform will tell you, look, this thing you put in there does not validate based on the rule I have been given. So let's try again. And honestly, that is super cool. I like tools that I can tell to think for me down the road, because when I'm first typing out my variables, I'll know, yes, this should never be string A, B, or C. It should definitely not be a Boolean. So let's get this set up now. 6 months down the road, you switch back to this project, you look at the code, you're like, oh, cool, I'll just use latest. Terraform goes like, no, perfect. Oh, note that the type value is not quoted because the value itself is not actually a string. Next, we'll add a description. And again, we'll specify default of latest. Now, if we update the Docker image resource with the correct variable reference, Terraform will resolve the content of that variable and we'll pull a version tagged as latest for the hello world image. So let's go a step further and remove the version default from our Terraform code. And I just typed out this code and I may not have set all spaces and indentations correctly. So before we test our resources, let's format and validate our code because that will tell us a few things. And for that, I can use the Terraform fmt command. This will clean up my code and format it according to internal rules. So Terraform has kind of like, you might be used to it from Go, where you can use Go fmt. It rewrites your code in a canonical way. So everyone has the same structure. And no matter if you write code here or in a completely different part of your organization, everyone has access to the same FMT and you're good. So we ran Terraform FMT. We're able to format our code, beautiful, probably some indentation that wasn't good. So next, we'll use the validate command. And we're going to validate the code we just wrote. And the nice thing about validate is it is a sanity check that verifies that the configuration files you have look good and the syntax is correct. But it validates that without checking any remote services or APIs. So these two commands are super quick, cheap in the sense that they don't take a lot of time. Usually it takes less than 5 seconds, even for the biggest Terraform repositories. So my recommendation is use it often. And we'll get to a great way of using both of these a little bit later. So Terraform has a large number of CLI commands, and you won't use all of them all the time. And you'll later see that I think most of the time we use maybe 4 or 5 commands. So if you're ever stuck, you can use Terraform help, find out more about a specific command and what it does. So we've initialized our provider, we validated our code, we've even inspected the help file. So let's test out our code. And so this is probably one of the most used commands that you'll encounter, Terraform plan. Running this will generate an execution plan, essentially a step-by-step guide that instructs Terraform. I want you to create resource A with provider B. I want you to create this storage backend in this cloud, and I want you to link those two together. Think of it as a run book, as a walkthrough. It's a very useful command because it removes the need to guess what will happen. Sometimes with certain tools, also, back 5 to 10 years ago, when things were still more often configured in a UI, I've been at places where we had guidebooks that had screenshot for screenshot what you should do, the intended result, and then you would look at your console and the intended result was not really what you were seeing because something changed on the provider. And now you're like, wait, which one of the 50 steps went wrong? You backtrack, it costs time. With infrastructure as code, that doesn't happen all that often. So to make our plan even better, we're saving it locally using the out argument. This way, we're building in additional, what's a good way of calling this, additional safeguards that even if something changes in the backend, Terraform will execute the plan exactly the way it showed to you, or it will fail. But when it fails in a way that you will know what went wrong, which personally, when I'm debugging, that's my preferred way. I want to look at an error message and see, hey, what went wrong here? Is it that I don't have access to something? Has my session expired? Did I mistype a AWS region? So many different ways. So Terraform processed our files and is now telling us what to do, right? And it even is very verbose at that. So Terraform will perform the following actions, right? Create a Docker image, name it hello world. And because we only have one resource, the final line is 1 to add, 0 to change, 0 to destroy. But imagine if you're creating, let's say, an EC2 instance, you're adding a security group, you're adding an EBS volume, you attach the EBS volume, obviously those numbers would change. So we see 3 attributes for the Docker image, named hello world. And for some of these values, Terraform already knows what the resulting value will be. We told Terraform that the image should be called hello world latest with a version tag of latest. But for others, such as the ID value, Terraform doesn't yet have that value available. So it tells us, hey, I'll know this after it has been applied. And this has to do with the way some values are generated. In the case of an ID of the Docker image, this is provided to Terraform by the Docker engine. Similar with, for example, an EC2 instance or an IAM user, you have ARNs, so Amazon resource numbers, that are only known once you have generated it. So our plan looks good. Let's provision our resources. And this is done using the apply command. If you remember from the previous plan, when we used, from the previous step, when we used Terraform plan, we specified an out argument to generate a plan file. And that file, the output from the plan step, now becomes the input for the apply step. And in general, TF plan files are for execution runs only. You do not want to commit them to your version control system because they don't make sense to be stored for a long time. So running apply, Terraform will execute our plan. And after a few seconds or minutes, that really depends on what kind of infrastructure you're working with, how many resources you have, this step will complete. And as you can see here, it took just a few seconds because I only touched a single resource. And if you have a look at the bottom of the output, you can actually see that Terraform has saved the state of our infrastructure into a file. And as I mentioned before, Terraform, I find to be very friendly. It tells you, okay, look, I've saved the infrastructure state. The state is required, take care of it. And by the way, it's stored in terraform.tf state. And that terraform.tf state file is a mapping of real world resources. So in this case, Docker image, to something that Terraform understands. And next to that, the state file keeps track of the metadata of your resources, such as provider identifiers, regions, settings that have default values that we might not even be setting directly, and many more things. So for example, you might have a Terraform resource called Hello World, which to you is super clear. For Terraform, that's not deterministic enough. So it actually tracks that resource through, let's say if it's a Docker image, through the Docker images ID, because that's going to be unique to your system. And that prevents collisions if you add a second resource. And so more importantly, especially for later, the state file also keeps Terraform performant. We have large scale infrastructures with hundreds or even thousands of resources. Sometimes when we talk with our customers, we see infrastructures where a single repository has upwards of 10,000 resources, and Terraform is able to work with that. But as an operator, I will tell you that's not my preferred way of working with it. So there's a couple of good things you can do to structure that. Terraform state is modular. You can have repository one consume state from the other, but those are very or slightly more advanced topics. So I've included reading material for that, but we won't actually be talking about that right now. So Terraform state is stored in JavaScript object notation, more commonly known as JSON. So you can process it with other tools if you have to. Terraform state, because it is a representation of your whole resource graph, has everything you need to know to make diagrams of your infrastructure. And there's a couple of tools available for that. So by default, whenever you run a Terraform init, Terraform plan, Terraform apply, your state is stored locally in a file called terraform.tf state. And we saw that before. And this approach is fine if you're the only engineer that's working on a project, but we really recommend storing it remotely. So in the code samples I'll share with you later, I've included some reading material on how to store state remotely, what options you have, why it makes sense. And actually thinking about it, there's a couple of things that are really good about storing it remotely. One, if your machine dies, your infrastructure is still available. Two, if you use backends such as S3 or Consul or any other backend like Terraform Cloud, they support state locking. So that means if I'm working on this project and my colleague wants to work on the same project, but I'm currently in a Terraform run, his Terraform will be informed that I'm working on this because both of them check the same state, and we'll see, hey, there's a lock on this file, and that lock was established 5 minutes ago. And so very likely that person is still working on it. Depending on the backend you use, you'll have some information available, and you'll know who's the person you should be talking to. And generally, everything you do in terms of engineering gets better when you communicate. So when my application tells me, hey, there's this error, and this is why I think it's happening, that communication helps me fix it. Same with state. Imagine if you're spinning up 100 EC2 resources while your colleague is doing the same. And they're identical. If you don't know that the other is doing that, and you end up spinning up 200, that might not be a good day to have. So let's get back to our code. As a reminder, we hard-coded the value itself for the variable, even though we had a dynamic reference in the Docker image. And so let's go a step further. I wanted to do this earlier, but I think we skipped over that and removed the version default from our Terraform code. So you can see we removed the default key value from the variable. And now Terraform has no direct way to resolve it because it knows that there's a variable called image version. It knows it should be a string. And it even has a description, but no actual value. So let's switch to our terminal and see what happens. And we're going to be using the same plan command as before. Hit enter, and Terraform immediately detects that we're missing a value and asks for input. And I'll type latest, and I'll confirm this with an enter. And Terraform continues with the planning phase. And since we only had one variable, that's all I needed to enter. But if you end up having 100 variables where you don't specify any defaults, Terraform will ask you for input for each and every one of them. That can be very annoying. So we'll talk about ways to solve this in a minute or two. And so if you look at my terminal, since we used latest as the user input, just like we did before, Terraform did not detect any difference between the first run and the second one where we removed the default value. And so no actions needed to be taken. And you get to see a nice green message, and that's good. So let's say we don't want to specify input interactively all the time because it's error prone, or because we're lazy, or because it's both error prone and lazy. And at the same time, we also really don't want to hard code our values in our .tf files and version them. Maybe we want to retrieve those values from somewhere else. So to keep our Terraform files clean, we can use variable definition files that end in .tf vars. And these files are key value based and allow for specifying default values that Terraform can pick up. And generally, the convention we have for those is that we end the file name in .tf vars. And if you name them terraform.tf vars or terraform.tf vars.json, remember Terraform state is JSON based, HCL is JSON, sorry, not JSON based, JSON compatible, HCL is JSON compatible. That's why Terraform can support values like this. So if you name them any of those two names, Terraform will automatically load them. Super simple. And for larger projects, you might end up having multiple of these definition files. You might say my terraform.tf vars contains maybe image versions, but nothing else, or region definitions, like the most basic information a project has. But you might have a different TFRs file for defining your user groups and another one for defining bucket names. If you make sure the file name ends in auto.tfrs, or again, auto.tfrs.json, Terraform will also automatically load these files. So let's jump back to our code editor. While I was talking, I magically moved the variable for image versions to a file called variables.tf to make this view a little cleaner. So now we can add a new resource for Docker container. And we keep the same name, hello world, because that's easier. And let's specify both a name and a dynamic reference to the Docker image we selected earlier. What you see here is, as far as I'm concerned, one of the best features of Terraform, dynamic references to other resources. So these references follow a super simple structure that works with all of the 125 providers that we support and all the other providers that are available as well. Start with the resource type, Docker image in our case, followed by the name, which is hello world. And finally, you specify the attribute you want to look up. In this case, we want the name. Behind the scenes, Terraform resolves this value and fills it in for us. And down the road, if the Docker image resource that we define on line 1, 2, and 3 changes, the Docker container resource will be updated without us having to change code there. Pretty nifty. So let's test this out. Already executed the Terraform plan command to save some time, and we can jump directly into the apply command. Remember before we just did Terraform plan -out Docker plan, sorry, docker.tf plan. See, I made a typo there. It will still work because I made that typo twice. Because when you screw up consistently, very important. And after a quick break, we can see that everything worked out as planned. So let's scroll down a little more, and there we go, another successful run. I like green text in my terminal. It is very soothing when Terraform or Ansible or whatever you're using does not come back with a load of red text. So we're nearly at the half point, I think, and you have learned pretty much the basics of Terraform. So while I can see you, I'm really hoping that everyone gives themselves a round of applause, because now, while we go into the AWS stuff, we could go into any other provider and it would still be clear to you what's happening. So we're ready to experiment with AWS, which is probably our oldest provider. So let's see how we're doing for time. Looks good. Abhilash, do we need a break at this point or shall we continue?
Kerim, some people are asking for the slides. It would be great if you could share a link or something if you already have it.
Absolutely. The slides will all be available later. I'm definitely going to clean up the .tf plan typo I made there. Everything will be shared at the end.
Great.
So if there's no other questions at this point, and we don't need a break.
Yeah, one. Do you prefer to have a break, you personally? Because like our break session was like off between the sessions.
Okay, I think. Let me see. We still have 40 minutes left, if I'm correct.
Yes.
I don't think I'm actually going to need 40 minutes because this was a hard part, and everything that follows is much easier. So we can do Q&A and make everyone, give everyone a chance to get their questions answered.
Okay. So one question in between. one of the guys were asking, like, what is the best editor to write and test the HCL code? So also, if I want to test with a newer version, say Docker, here, how do you test them? So that's what you answered. But then that editor for the HCL code, you have any suggestions? Almost all the editor works, but still.
So testing new code with a new provider is always interesting, because obviously you're touching real resources. So let's say you're upgrading from the Docker provider 2.7, and as long as you stay in the 2.7 range, no new bugs should appear. That's our intent, as with every software engineer. But let's say you're switching to the Docker 3.0 provider. Sometimes we add resources, sometimes resources change. It doesn't happen a lot. When it does, the first part to check is always our documentation. Like, for example, for the AWS provider, which we're going to look at in a minute or two, we're currently working on version 3.0, which is not ready for widespread use. So there'll be some upgrade things that you need to do. And generally, if those things are really wide-reaching, then Terraform will tell you what the changes are. But you're right, sometimes it can be a little bit involved. The beauty, of course, is because we define everything as code, and if you remember from before, we can spin up a new environment easily. So let's say you have your 2.7 code with 100 resources. You take everything, you have a single Terraform TFRs, which specifies the Docker host. And if you remember, I had localhost, but let's say I have a second Docker engine running on my computer, then I could specify that one, and I could have Terraform execute its test against that. And then the first one would not be affected. Same thing works with AWS. What we generally do is, in my previous jobs, we would either switch AWS region. So for example, generally we would do EU West 1, which is Ireland. And then if we need to test something real quick, we would use EU Central 1, I believe, Frankfurt. If your cloud provider has the same kind of resources in both, Terraform will just make a direct copy of everything and you're good. And that makes it so easy to test. Update some host names and you're good.
So Kerim, I had a question. So what's the workflow you would recommend while using Terraform with Docker? I mean, how does it fit in?
Fell away for a second. What was could you repeat the question?
Yeah. So what's the workflow when you're using Terraform with Docker?
So what's the workflow when you're using Terraform with Docker?
Yes.
First, you'll want to have a Docker image available. You can either find those on Docker Hub, you can build them yourselves. You can use our tool Packer to build them, which is also HCL based, which is what I referred to earlier. You learn one language, and you can use it for all our tools. So anyway, you have Docker image. So you add that to your Terraform code, you spin up a container from it. For that container, you define volumes, you define ports, entry points, everything else that you need. And now your image is in Terraform and you can just access it. With Docker, it's a great example to learn, but the workflow is limited because it's not super interesting. But essentially add resources, number one. So type them out in the code, Terraform plan to see what's going to happen, Terraform apply, and you're there. And if you're so inclined, at the end, you could say Terraform destroy. which we'll talk about in a second. All right. And if we have no other questions at this point, let's go into the AWS provider.
Yes, we are good.
Awesome. So this is probably what you all came for, which is how do we manage AWS with Terraform? So I mentioned before that Terraform has 125 officially supported providers. And of course, AWS is one of those. In fact, I think it might be the oldest provider we've had. It's definitely the one with the most GitHub stars. And that's because it just makes sense. I mean, every time reInvent happens, AWS adds 50 new services. And honestly, it's just impossible to know what they all do. So I let the Terraform AWS provider engineers figure the problem out, and then I can just use it. So the AWS provider for Terraform supports 175 distinct AWS services. No matter if it's EC2 instances, volumes, IoT endpoints, SNS, workspaces. I think we even added, what was it, Ground Station a while ago. We add support for new features and services based on community feedback. The maintainers of the provider are super responsive. So the more upvotes you give to a feature in GitHub issues, the more likely and the more quickly it will be added. So the provider team aims to release on a weekly basis, and they've been going pretty strong with that. Now, weekly releases doesn't mean that you need to update all the time, but it certainly helps to stay in touch with what's happening. I think, especially relating to the previous question, let's say we start out with 2.6, and the next time you look at Terraform's AWS provider is when it's 3.5. Your life might not be as great, and you might be spending some time on updating and upgrading. So I recommend checking the changelog every once in a while. And with a weekly release cadence, actually, since I started working on this presentation, I had to retake the screenshot twice. Yeah, it's pretty nice. So let's go back to our editor again, and let's start by adding a provider. You already know the basics from earlier, so I'm going to skip over those. But quickly, a version, and in the case of AWS, we also set a region. So the AWS provider team that works on the Terraform provider is pretty good with adding new resources and regions in our weekly releases. So generally, we're able to support a new AWS region within a week of it being made available to the general public. So in the last two releases, we added, what was it, South Africa, Milan in Italy. It goes very quickly, which is good because that means you can use Terraform in that region as well. So with Docker, we didn't really need to have credentials because we're talking local machine, right? With AWS, we do need credentials. And there's a few ways we can go about this. We can add the credentials inline and just hard code them. And just thinking about that makes me sad, because if you find those files, people still do this. If you go onto GitHub and you type in access key and you filter by, I think, .hcl or .tf, you'll find a lot of people that do this wrong. Don't be that person, because bots scrape those access keys and secret access keys, and they will spin up a lot of infrastructure that you will have to pay for. So maybe we should define them as variables, which at least means our TF files won't have them. But hard coding credentials into any Terraform recommendation is not recommended because it risks secret leakage. If the file gets committed to a public system, either intentionally or unintentionally. So maybe we do it slightly differently. If you work with AWS, you very likely have the AWS CLI installed. And that means in your home directory, you have a credentials file or a creds file, depending on the version you have, and we can use that. And this is cleaner because now you're using something that you're not very likely to commit. At least I don't know about you, but I generally don't commit every file I have in my home directory because I know that there's secrets in there. Next option, we define the access key and secret access key as environment variables. And this is a good approach as long as you trust the system you're working on. The thought is, of course, if you work on, let's say, your laptop or your desktop, and you don't trust the machine with the credentials, maybe that device should not be part of your infrastructure. So using this approach, we also don't have to hard code any credentials in our code, which means no secrets end up in our state files. And that is always a good thing. If you look at the code at the bottom in the code editor, I can share that with anyone. I can leak that file and not have to worry, because at worst, you'll see that I have a typo next to profile, but I have an AWS profile called Hug Demo, which doesn't tell you anything. So I should mention, for more advanced use cases, it's really worth to check out our Vault product. With Vault, you get short-lived credentials that are rotated automatically for you. And even if you leak those credentials, usually by the time they end up somewhere, they're already worthless. So somebody just copied a piece of text that looks like credentials. So we've created a provider again. We've supplied credentials in any way that makes sense, and we've successfully executed Terraform in it. And if you remember from before, what happens is Terraform downloads the provider binary. All of those are separate, and they don't actually ship with Terraform, which means Terraform is much smaller. And I think that's beautiful, because if you consider 40 megs per provider, approximately, depending on the size of it, of course, 125 providers, official ones, that's a lot of storage. Would kind of feel like node modules. So let's create an EC2 instance. First, we'll define a few variables, one for the AMI ID. I'm using, I think this was the Amazon Linux 2 AMI here. And I think this one was the one that's set up for HVM and SSDs, like a fairly default one. And so you see that I'm hard coding the ID value here. And that is fine, because I want the AMI ID to become part of my public log. This way, rolling back is a lot easier, because this ID is something that AWS tracks for us. So here we're using an official Amazon machine image, or AMI, but we could also build our own. I think from one of the questions before, I mentioned that you could build your own Docker image using Packer, but Packer, another one of our tools, is great for defining code that you can turn into any kind of image. So it could be a Docker image, VirtualBox image. So you can run it with Vagrant. AMIs, of course. Pretty much anything that's listed in the builder section will work for this. And then back to our variables, we add another one for instance type. And let's scroll up a bit to make it a little bit more readable. And let's add another variable. I think this should be the final one for availability zone. All right, that's it. Save this file as variables.tf, and let's create a new file. And we'll call this one instances.tf, just to make it easier to see what's happening. The same as before, we define a resource, and this one is of type AWS instance, and we name it Hug Demo. So let's populate some of the values here with the variables we defined before. And if we now plan this out using Terraform plan, Terraform will render our resource graph, and we'll write a plan file. And even better, it will show you the changes it will make before it makes them. And that's honestly a nice promise to have. So in the code example, I've highlighted that this plan would add one resource, doesn't change anything, doesn't destroy anything, because we're just getting started with the provider. But it's nice feedback. And generally, when you run a TF plan, a Terraform plan, you get a lot of text, especially with an EC2 instance. You end up getting probably 30 to 60 lines of code back, because when Terraform talks to the API, it gets data back on the volumes that are attached to it. It gets data back on the placement zones, security groups, ports, IPs, everything. I've stripped those out because for our demo, they're not really important. But if you run the code I've included, it's going to be super useful. So our plan file looks good. It was saved to aws.tf plan, and we can apply it. And this step will take a bit of time, because in the backend, Terraform is communicating with the AWS API and is instructing it to create an EC2 instance. And we're lucky, I guess, because we only have one. And here we go. Our instance is now created. With EC2, this is fairly quick. Took 22 seconds, which honestly is still a lot longer than I would hope this would take. But let's say you're doing something like an RDS instance. That gets a little bit harder, because let's say you're starting an RDS instance the way AWS recommends it. So RDS are database servers. You want to have a backup. Each one of those takes 15 minutes to start up. So your Terraform plan will take a few seconds. Your Terraform apply might take 30, 35 minutes to complete. So let's have a look at the EC2 console if it loads, and this might take a second. Here we go. Running EC2 instance. And the beauty is, all of this is defined in code. So if I share my file with you, you can create the exact same type of instance in your AWS account. Of course, it wouldn't be in my account because you don't have my credentials, but other than that, the instances would still be identical. So let me quickly go back. Let's see. Oh yeah, so here's a fun thing I can show you. We created an EC2 instance. And let's say the included disk is not what we want. It's too small, it's not the right type. It's going to be easier if we just add our own volume to it. So we'll create two more resources, an EBS volume and a volume attachment. Those are separate because you can create disks in AWS, but just decide to never attach them. That means that disks are pretty pointless because they don't serve a purpose, but you can. And when you're ready, you use the volume attachment resource to actually attach a volume via the AWS API. So we've created those instances and volumes, and obviously we want to have them be part of our EC2 instance. And we've attached them, and that's all nice. It worked out. We did Terraform plant, Terraform apply. But if you remember, Linux doesn't automatically mount a disk. So usually you'll end up using something like, what's a good tool for this? Maybe Ansible. So question, of course, is how do we get the name of that instance, the name of that volume into Ansible? And the answer for that is variables. So let's create a new file. We'll call this outputs.df. And we create an output named volume device name. And outputs have a very similar syntax to variables. So if you think of variables as inputs, and outputs are clearly outputs, it all makes sense, I think. So then we add a key of value. And I know it sounds confusing, but bear with me for a second, because we populate that key's value with the interpolated value of the device name of the volume attachment we have. And I promise you, this was as confusing to say as it sounds. But if you look at the code, it actually makes sense. Because if we now apply this, you see Terraform is refreshing the state and checks for any changes, and finally outputs the newly defined output. And at the bottom, you can now see volume device name equals /dev/sdh. And this is useful when we run it through Terraform, but sometimes you need to consume an output directly. For example, if you're running a script, maybe you want to use it as a shell input for Ansible. Maybe you want to have it in a reporting tool. There's many options. So we can use a Terraform output command for this directly if we don't want to apply. And this would print out all the outputs you have after at least completing one Terraform apply run after adding an output. Because we only have one output, that's how many we see. Let's say we've just created 10 EC2 instances. All of them have different devices. And I see there's a typo there. We'll get that fixed before I upload the slides, so I apologize. In that case, you do a Terraform output with the output name, which if you we named it volume device name. And the response we get from Terraform is /dev/sdh. And you can use that value any way you want. So we've experimented a lot. We've started resources, downloaded providers, and we have spent some money, which is always good because that's generally how you learn in the cloud. But we don't want to leave stuff running all the time. So let's see how we can terminate resources. And I briefly talked about this before when we talked about the workflow. You init, you plan, you apply, and you destroy. So Terraform has a destroy command to remove any infrastructure Terraform manages. And this is useful because AWS resources cost real money. And at the end of the day, we shouldn't be wasting that. With Docker, it's still good to clean them up, but it won't cost you as much because you're running it locally. But just like with apply, we first want to see what we're about to remove. So let's use the Terraform plan command again. But this time, we're adding -destroy to the end. This will generate an execution plan of resources that will be removed.
And as before, we can apply this execution plan by running Terraform apply and appending the .tf plan file. So it takes a few seconds or minutes while Terraform removes all of your resources. And here we go. Beautiful, another successful operation. Even though it was a destructive operation, it completed as intended. So we're good. 3 resources have now been destroyed, and we're no longer paying for them. Now, Terraform also has a Terraform destroy command, which works the same way apply works if you don't use a plan. Essentially, you run Terraform destroy, you see a plan, Terraform asks you for interactive input, you type yes, hit enter, and everything gets shut down. While that can be useful, it's super easy to miss something there. So it's always better to use Terraform plan. It also helps that your workflow is already Terraform plan, Terraform apply anyway. And now for destroy, you just do Terraform plan -destroy. So we've completed a full Terraform lifecycle. We started with Terraform init to set up our provider. We specified a version for it. We wrote some code. We had some typos in there. So we made sure it's clean and nicely formatted. And for this, we used Terraform FMT. We followed up with Terraform validate to make sure the syntax is correct. Then we generated an execution plan using the Terraform plan command. And finally, we saved the execution plan locally because that's the best approach. And then we applied the execution plan. All in all, super simple. Finally, we decided we're done experimenting now. We created a destroy plan by adding -destroy to plan. And that's pretty much how a basic Terraform lifecycle looks like. So if we go back a slide real quick, init is something you run once, format, validate, you should run all the time. Plan and apply is where you live. So type something, plan it, apply it. Miss something, cool, let's try again. So so we've got one more part that I want to look at, and I promise is a quick one. I know you've gotten a lot of information right now, and you're probably excited. So I want to help you on your journey a little bit. So let's have a look at how we can scale Terraform. So oftentimes you may already have resources with a provider, and you want to bring them into Terraform. Let's say we have a handful of S3 buckets. So we'll start by creating a new Terraform file, or we can add this to any other existing one. And in this case, I want to import S3 buckets. So I first define a Terraform resource of type AWS S3 bucket. And we specify the name of hug_demo for the resource type. And we named the bucket hug demo, which is also how the bucket is called, like in my AWS console. Then we switch to our terminal, and we start with the Terraform import command. Now for the import to work, we need to specify what we want to import into. So that the Terraform resource, so what the Terraform resource is, and then what to import from, and that will be the AWS resource. So first, if you remember the code we just wrote, we specified a Terraform native resource. In our case, that's the AWS S3 bucket. And then we append the resource name. So that's hug_demo. And then we specify the AWS resource as a string. Very straightforward. And that's generally the theme with how Terraform import works. It is very straightforward, but it is resource specific. For example, S3 buckets only require a string, but an IAM user might have a much longer string that includes the AWS region, maybe an AWS account. The good thing is you don't have to remember those things. For Terraform, all resources specify their import syntax at the bottom of the documentation page for that resource. So if we go to the S3 bucket resource, scroll all the way to the bottom, you'll see exactly this line, maybe with a different bucket name, but ready for copy pasting. So now if we run this, Terraform will communicate with the AWS API and learn about the resources. And then Terraform will actually import the resource into our state. So unlike validate, this is not something that only happens locally. This is definitely something that happens remotely. And it works pretty quickly, like generally no more than 30 seconds for a single resource. And in this case, I think it was maybe 2. But the import command only really scales if you have a handful of resources. It is very cumbersome if you have multiple regions, lots of instances, maybe databases, maybe even stuff you don't know about because you weren't the one who created it and it was never codified. For those cases, you probably want to use the Terraformer application, which the SRE team at Waze maintains. And that one is beautiful in the sense that it scours your AWS account, finds all the resources, and then writes the Terraform code for you. Now, of course, it doesn't know about variables. It doesn't know what should or should not be imported. So all your code is going to be very verbose, but you just save yourself the trouble of importing 100 resources and making copy-paste errors. So it's a fair trade-off, honestly. So I think that covers pretty much all the basics for today's session. So let's review quickly. We learned about providers and how they enable Terraform to communicate with a large number of external resources. We looked at the Terraform lifecycle. So from initial setup to code validation, plan execution, and resource destruction. We talked about state, and just to remind you, Terraform state can be stored locally or remotely, but you must keep it safe as it is a source of truth for Terraform. If you remember terraform.tf state, the file, if you throw that away and you run a new Terraform plan, Terraform will not know that anything that you previously created exists and will try to recreate it. And if the resource has a unique name, it will actually error. So I think we had a couple of questions about this. If you want to try the things I showed you today for your own AWS account or on your Docker host, take a note of the link that's shown. I'll also post it in the chat message in a bit. On the second link, you'll find code samples, further reading material that I think is useful, a couple of learn guides. And then if you want to read more, on learn.hashicorp.com, you can find very nicely structured guides on how to use Terraform, Vault, Consul, Nomad, Vagrant, Packer, pretty much everything we built. And if you use the link that I actually have behind me, you'll be taken directly to the Terraform section and actually more specifically the AWS section. And if you have questions, but you don't want to ask them in a live chat, that's cool. Head on over to HashiCorp Discuss. which is our community forum where you can talk to other practitioners and employees. And this link will actually take you specifically to the AWS provider forum. So you can ask questions specific to that. And then finally, from June 22nd to June 24th, we're organizing the first digital edition of HashiCorp. Registration is free, so I highly recommend signing it up. It's in CEST time, so 3 hours before you. We have keynotes, we have product announcements. We'll have daily workshops from one of our engineers. So you can pick up new skills, you can ask questions. It's going to be very nice and unlike any digital event you've been to. And now that your head is full of ideas, grab a notepad, write down your ideas, and share your story at one of the next Hug meetups. My name is Kerim Satirli, and it's been a pleasure to talk to you today. Now, what questions can I answer for you?
Kerim, there was one question about using AWS SSM Secret Manager.
Yeah.
So, yeah.
Let me
So
quickly
how does it
switch
fit
to
in?
my other headphones.
Yeah.
Because technology always fails when you don't want it to, but always when you should expect it to. So the question was about AWS Secrets Manager. Let me see if I can pause my screen share. And see if I can find the actual question myself. Or maybe if you happen to have it available and you can read it out.
They didn't ask actually much in general. They just wanted to know whether we can store our AWS secret keys on AWS SSM. I think it was for managing huge teams.
Yes. You can definitely store your secret keys in SSM, but it's not the first approach we use. Mainly because, well, one, we make the Vault product. So for us, it makes sense to use that to provide AWS access. But let's say you want to store them in SSM. As long as you're able to expose those to your environment in a way that your environment somehow is able to render them, then yes, you can retrieve them from there.
We just wanted to know whether we can.
Sorry, can you repeat that?
No. Harsh, are you there? Harsh?
Yes, I'm here, yeah.
Okay. Yeah, there's another question. You mentioned about the Terraform destroy, but can we avoid destroying the dependencies? Like, for example, does it destroy the attached EBS volume? And if he can, if he don't want to destroy the EBS volume, how do we do that?
That's a great question. Yes, you can definitely avoid that. It's pretty much the reason we have the EBS volume in the first place, right? We definitely don't want to have, we're fine getting rid of the virtual machine, but we want to store the data. So in Terraform, and I'll update the code examples to put this in. This is a beautiful question. In your Terraform code, you can say for lifecycle changes, ignore certain parts. So you could specifically terminate your EC2 instance while keeping your EBS volume alive, which is very much what we want. Sometimes you just want to start clean with a fresh OS, which is on the virtual machine, but you want to keep the data because that's really what it's about. So yes, I don't have a code example for this right now, but I'll add it to the GitHub repository, and that will make it a lot easier. And as soon as I'm done talking, I'll also share the link in the chat.
For some
So-
reason, we are not able to share the chat links in the chat.
Yeah, I think that's a YouTube issue. I'm able to share links because I'm listed as a moderator. But if you just send me the links in our chat,
Yeah,
I did.
then
I just did.
let me just grab that real quick.
Okay, there is one more question, Kerim.
Yes.
So he's asking, like, how do we, is there any few Terraform commands which will help us in troubleshooting the errors?
So Terraform FMT format and validate are my two preferred ways of doing this. And what I also very much like is, let me switch us to the primary screen. So Terraform FMT and validate to me are awesome to work with because they tell me if my code has a problem before I even apply it, which generally is what I want. What both of them don't do is they don't really help you with misconfiguration. If you tell Terraform to start up an database server with a 100 gigabyte hard disk, and you completely forget about that, then Terraform will do that. It's a powerful tool, but it won't necessarily protect you from that. But we're working on specifying variable types where you have enumerated values. So down the road, you'll be able to say, the range of my disk needs to be between 1 and 5 gigs and not more. And if you specify 100, you'll get an error. Now that's for the future. For right now, what we use is Terraform format, Terraform validate, and an external tool called Terraform lint or TF-lint, which can go through your code base. And especially for the AWS provider, we'll actually tell you, hey, you're trying to start up a T6 micro instance, which is not a supported type. So as a result, it won't actually execute Terraform for you. So think of it as a wrapper. And then we're also working on a tool that can help you define your code in a cleaner way and more securely. But I think that might be slightly too much for today's session. Definitely a good question. So I'll add that to the code repository. And I think it should be a lot easier that way. Code like this, I think, is always easiest if you can just copy, paste, play with it yourself. That's what I like anyway. So I see there's a lot of more questions on the chat. I think I'll get to those in text form. And Vishnu, I think you are ready for your session. So I'm just going to hand it over there. Thank you so much. It's been a pleasure. And Vishnu, you're up next.
Thanks, Kerim, for your lovely session.
Vishnu,
Yeah.
I believe we may need to give some break, like 10 minutes break. We'll be back and we'll keep this live. Kerim, how do we take this? Shall we just introduce, keep on going so that they can take the break?
Yeah, so I think the easiest way to do this is to just keep the stream going. People can ask questions in the backend, and we can get to those. I'm able to answer them right now. And while we take a quick break, I think that should work.
Yeah, that sounds good.
Yeah. So, guys, if you have any questions, you can keep on asking in YouTube channel. We'll answer them by 4:45, in IST, 4:45 IST, that is in 10 minutes time. We will start our session on Consul. It will be again a beginner session. So yeah, thank you, Kerim. Thank you.
My pleasure.
Yeah. So I hope
it was helpful.
Yes, it was. It was.
Very nice.
Yeah. So there are a lot of other requirements coming up. Like, we had 2 sessions asking where is there any can we do a session on Terraform plus Google Cloud? Then there are
absolutely.
So then there will be like a kind of like a 200 session or 300 where he is asking if he can CI/CD pipelines on Terraform, which will be more advanced.
Yes, mostly because you now know the basics. Building on that for GCP is going to be very easy.
Right.
Can always just ask Katie. I'm sure she'll find somebody.
Yeah. Personally, I would like one on Terraformer, the one you mentioned. I thought it was restricted to Google Cloud, but you just told me that we could use it anywhere.
It's definitely an interesting tool. Like I said, I like my code to be super clean. I hate it when things are hard-coded, and if you import a full AWS account, you end up with so much hard-coded stuff, which just because of the way it works, Terraformer could know that it should turn things into variables. Like, from a technical perspective, it's nearly impossible to guess what should be a variable and what shouldn't be. I mean,
it's hard
you
for
could say,
anything. That, of course, but I can understand the difficulty. It's hard for humans to do it as well, so I can understand the difficulty systems are having.
Yeah, it's not perfect, but it definitely beats typing out all those resources by hand. Yes. My personal way of quickly importing a single resource is to write out the minimum required Terraform code. So for example, in the case of a bucket, it's I think bucket name is the only thing that's really required, because region is inferred from the provider you're specifying. So super simple. Import the bucket, and maybe that bucket has a website configuration, maybe that bucket has course settings, maybe that bucket has lifecycle configuration. Terraform will then tell me, because it does drift detection, that my local code only specifies the bucket. It doesn't specify everything else. But the way Terraform tells me that is by writing out that code. So I can copy and paste that code, remove, I think, the pluses that are in front of it, or the minuses in this case, and I kind of have my code available. But that's if I don't have Terraform available.
Yeah, one of the guys are asking, like, he has been like, he's asking Rag K, he's asking like, is there any good links or how and when to integrate both the Terraform plus Ansible?
Terraform and Ansible is, honestly, it's like a dream team, right? So for me, I think I started using Ansible just when 1.8 came out, and then with 2.0, they added a lot of cloud modules, but it still wasn't so easy to get it to use. And that's because Terraform is designed from the ground up to talk to cloud resources. So in Terraform, you would specify all the outputs that you need, and then Ansible can just consume them, either through, what's a variable called? Shell. It's not a shell variable, but if you write Ansible, you know how you can get values into it. You could run something like Ansible -playbook --extra vars, and in the extra vars, just execute Terraform output with the output you need. Not the cleanest, I'll give you that, but it works. Another option, remember Terraform has 125 providers. One of those is the template provider. So you can have Terraform generate a template for you, and that template can contain all the values Terraform has. So for example, let's say we're creating an EBS volume again. and that EBS volume has a mount point, it has a size, maybe a file system. Maybe we do things based on those settings, right? You have Terraform, Terraform's template provider render a file in the format that Ansible can understand, JSON, YAML, whatever you need. And your workflow would then be Terraform plan, Terraform apply. Terraform apply renders the template file, and then Ansible dash playbook. Man, I'm blanking on the exact Ansible command, but Ansible could then, through its playbook, ingest a generated file, which should be a configuration file, a variables file. Not, you shouldn't have Terraform generate an Ansible playbook, because I think that's silly. But yeah, it's definitely something that can work like that. And I'll add a few links to those in the code. And once I'm done, I'll also upload the presentation so everyone has it available. Because I know there was a lot of code, and it's a lot easier if you can just copy and paste it. So in the meantime, I think you had a URL for me. And let me just post this.
There are a lot of future session requests coming up.
Yeah, I can definitely see that. There we go. So that's the link for the Google form you mentioned. Which is always nice. Vault 101, definitely a good one to have. All right, so just quickly running through the chat, I see a couple of questions on modules, which, so we still have 3 minutes, I think, before the next session. So let's use those productively. Modules are definitely a super good way of working with Terraform. Honestly, it's my preferred way, because even if I just have a single resource, building a module around it, for me, makes it a lot cleaner to work with, because it makes me think about my my dependencies a lot more. It makes me think about documentation. And at the end of the day, you know, right now you're planning for a single EC2 instance. Yeah, and then, you know, your team is excited because it works, and now they want you to make 100. So you could copy paste your code, and that would work, but it's a headache to maintain. And it means that if any one of them changes, now you need to update 100 resources manually. So it's like infrastructure as code, but still hurting yourself a little. Build a module around it. You define the code once, you add the module, and then you just call the module. And rather than writing out 50 lines for every EC2 instance, you can write out 1 line. 3 lines, because you have the name of the module, the path to the module, and whatever variable you need to change. So still super, super simple. And yeah, in the code repository, let me just grab that and put it onto YouTube right now. There we go. In that repository, I'm also talking about a few of the more advanced topics, such as running pre-commit hooks, so you don't have to run Terraform plan and apply manually. I'm talking about, I see I haven't committed the change to the registry stuff yet, but I'm definitely going to share that as well. So we have a Terraform registry, which is like any other package registry, only it's for Terraform modules. On there, you'll find pre-built modules for AWS, for GCP, for GitHub, pretty much everything that you can, everything and anything that you can imagine, and that you don't want to have to think about. And I think that's, yeah, honestly, I think that's a really good approach.
Yep. So thank you, Kerim, once again.
My pleasure. And now I'm curious to learn about the Consul.
Vishnu?
Yeah, hi guys. Let's hope so.
Okay. So Vishnu, guys, Vishnu is a senior AI/ML DevOps engineer with the Jumio Corporation. He will be taking the sessions of for the Consul 101. He'll be talking a little bit of microservices architecture, so that you can just start off with the basics of microservices, why Consul is used, and then he will take the one-on-one sessions when you can ask questions, the normal pattern. Okay, over to you.
Yeah, hi guys. So I'll share my screen once again. Ablash, can you see my screen? So?
Yeah, I can see, but the entire screen, you have an option to take only the.
Yeah, is this fine?
Yes.
Yeah. So guys, I've been using HashiCorp products for quite a while now, like Terraform, Consul, Vault, Packer. It's been 3-4 years, and really excited to take a session on one of that. So today I'll be presenting some demos on Consul, mostly based on a user perspective, like practical examples, and also I'll try to explain something about the architecture of Consul and how they work, how the cluster setup work, all those things. So this is going to be 1.5 hours, so be with me. Let's see how this goes. So my name is Vishnu. I work as a senior DevOps engineer at Jumio Corporation, and we basically deal with identity verification with AI and ML enabled architecture. So we use Consul here, Terraform, Packer, all those things we use in our company, my previous companies everywhere. So let's see. So before I begin, like, I just want to give a history of how things used to be. You remember like 5-6 years ago when we were working on infrastructure architecture, everything used to be monolithic. You had, say, one server with one app running in it, maybe connecting to a database in another server with one IP for that server. And nothing really happened there. So if you wanted to scale it, you mostly would vertically scale it, like increase the RAM, CPU to increase the performance, or if you're under load or something. Because horizontally scaling was pain because say launching one more server, starting the application, adding it to the load balancer, installing everything needed in that server. So it was quite a mess. So once this changed into these microservices architecture, and even infrastructure design and architecture has to evolve, right, to support all this portability and agility of these microservices. So say these are the, what you say, the basic structure or basic design of a microservice. So they move around a lot. So introduction of the Docker technology made these applications, we can containerize them, and they are portable now. And they're loosely coupled with each other. So imagine there is a OTP service. It is inside one Docker. It is talking to just one data, so like Redis or something. So it is loosely coupled with the other services. And these services, they are managed by smaller teams, and the introduction of all these CI/CD stuff made these So talking about, they were deployed by, say, independent teams with all these CI/CD pipelines. They can deploy it whenever they want, rather than like waiting for a month or a week to have the release in. And with the introduction of all these, say, multiple clouds like Amazon, Google Cloud, and people started using different services from different clouds because of their feature list or because of price or whatever. So application had to connect to services in multiple clouds and all those things. And to handle all these agility, it was not possible for architectural design of a legacy system, like you manually adding stuff into a load balancer and all those things. It was not practically possible. So this requirement wanted us to evolve our design, use softwares which help us to make this easier. So that is how we started looking for systems which will help us with all these requirements. So let's see what all things we would need in this agile environment when things are moving around. So we need some kind of service discovery, right? You can't track an application where it is running. These are Dockers. It can be deployed anytime. So once it is running in one server, after the deployment, it might be running in another server. Maybe another use case where you increase the replicas of the application, an autoscaler kicks in, then the application started in a different mission, and now to manage the requests going to these applications, it was not possible for a classic load balance to work. So we needed some kind of service discovery, like to see where this application is running, to track where the application has started up after the deployment. So that is one thing we will be trying to solve with Consul. And the next thing we wanted to solve is like load dynamic configurations in. So imagine there are a lot of use cases where this thing is a requirement. Like you don't want to have static configuration coded into your code base in such a environment, right? Say you have an application and it is deployed using Docker. So you have the code base inside the Docker, everything is fine, it is working fine. But imagine you are having like three environments. You have a test environment, you have a staging environment, you have a production environment. And in each environment, this application has to connect to a different set of infrastructure service. Say, imagine your app one want to connect to Redis. So it wants to connect to test.redis.com in the test environment, while in prod, it wants to connect to prod.redis.com. So you don't want to have three sets of code base to manage this, right? So you keep the configuration data prone to change in an external resource. So you can fetch it whenever you require. So when you start the application in test environment, you can pass some variable or something and make the Docker know that you are starting in test environment, and you can ask the application to fetch the values which are required for the application to start in the test environment. Simultaneously, the same thing happens when you start it in production environment. It loads a different set of endpoints or whatever it is. And another use case is, as I told you, like people started all these hybrid clouds, and you use one service from Amazon, you use another from Google Cloud. So you have to support that. So you needed to keep this data in both the clouds, because more from a disaster recovery scenario or from a latency scenario. So Consul helps with this also, with the feature of multi-data center. You can share data between two clusters, and you can utilize that when you are deployed services in multiple data centers or multiple clouds or whatever. And with the introduction of Kubernetes and all those orchestrators, schedulers, you needed service meshes, you needed security policies, you needed routing based on ACLs and all those things. So Consul also provides service meshes and a newer product which came last year, I guess, was Consul Connect, which we won't be covering in this session because it is a one-on-one and I want to keep it as simple as possible. So let's go into the Consul architecture. Enough with the introduction, I guess. And as a warning, if you see any resemblance of the images in my slide to something in the HashiCorp GitHub, it is purely coincidence and I didn't steal them. So Consul architecture. So on the right side, you can see a representation of how a Consul cluster or multiple data center will look as. So when we talk about cluster, in the case of Consul, we call it as a data center. So a set of servers acting in the server mode, we can call it as a data center along with the clients, the Consul clients. So a data center is made up of the server nodes, which are here in the diagram, and also the client nodes. And that's the best thing I saw about Consul. You don't need a fleet of server nodes to handle 100 or thousands of client nodes. With 3 or 5 server nodes, you can actually take the load of hundreds of client nodes, which is actually quite impressive to design a system like that. It is quite cost efficient and it is so good. Then when it comes to the set of servers, which is here, we have one leader and the other 2, or if there are 5 servers, the other 4 will be the follower and 1 will be the leader. So leader is elected using the raft algorithm. You can read about it. It is like what you say, finding a easier way to match the values and see who is more eligible and setting him as the leader. So if the leader goes down due to some problem, like the machine in which the leader was working is currently down or has some problem, using the raft algorithm, a new leader is elected from one of these followers. And the leader is responsible for processing all the queries and has the sole right authority to the key value store, among other roles. And all the agent communication happens with the Gossip protocol, and it works both over LAN and WAN. And you can read about Gossip protocol in the Consul documentation. It is quite extensive. You have to go really deep into it, which I'm not covering today. You have to read about surf algorithm, swim, everything to understand what happens in the backend. And WAN Gossip allows you to talk between 2 data centers when they are maybe separated between 2 clouds or 2 data centers. So next, say, we have the Consul port. So Consul listens on a number of ports when we start the service in a server or a Docker or something. So there's mainly 5 ports, and when you combine HTTPS, all those things, there'll be more ports. So 8600 is the port in which the DNS interface works. 8500 is the one in which the HTTP API and all those things work. And then we have 8301 for LAN and 830 for WAN surf protocols and 8300 for the RPC. So I spelled it wrong, it is RPC. And so let's talk about what we mean by service discovery, and we'll go into a quick demo of that. So service discovery, like, let me put it very simple. One second. So say if we want to dynamically provide data to locate an application or an infrastructure service, that is a core idea of service discovery. And with Consul's service discovery, it integrates health checks with it. So imagine you're not only saying a service is there, you're also saying that service is there and it is healthy. And you can configure health checks with TCP health checks, HTTP health checks, and also you can configure custom script health check if if your application or the service needs a custom API to understand it is healthy. And Consul also provides a API interface and also a DNS interface to leverage the use cases of service discovery. So if you are designing an application to find out where another application is, you can use the Consul API interface. And if you don't want to code in all those stuff, you don't want to write the code to fetch all these details, and you just want to rely on a simple endpoint like a classic DNS, you can still use Consul DNS interface. And these service discovery stuff can be easily integrated with like proxies and other third-party softwares. So HA proxy can find a application from which is listed in its backend without us human like coding in and restarting the HA proxies and all those things manually. And with the sidecar features in Kubernetes and all, you can easily integrate Consul with Kubernetes if you want to go in the Consul way rather than using the Kubernetes service discovery, which is there by default. So that's it. And I just want to talk about the DNS interface also. So the API interface is where you have a HTTP endpoint and you can query it to get the details you want. And similarly, we have a DNS interface, which allows the application to make use of service discovery without like having, as I said, you're coding in all those stuff or having the Consul libraries and all those stuff in your code. And to make this work, you'll always have to reconfigure your local DNS server or the DNS servers your application uses to add Consul as a resolver or add subdomains in case of Kubernetes and all those stuffs. And with DNS interface, Consul provides both node lookup and also service lookup. So you can also look up the node in which an agent is running, or you can also look up where the services are running. And by default, these are the two TLDs you can use in Consul, and this is also configurable. It is not fixed. So you can use say app1.service.consul.com, Consul, not .com, sorry, app1.service.consul, and you can actually find where that app is running. And if you have more than one replica behind that DNS, it will do a round robin load balancing for you to send the request to. Yeah, and let's go to some demo for our service discovery, and I hope it goes well. So let me go to my terminal and let's see. So for the easiness of my demo and for nothing to go wrong, I have coded in and also kept some Docker Compose files so that I don't have to search around. So I presume that everybody understands the basic concepts of Docker and how Docker Compose works. So Docker Compose actually starts a set of Dockers which are interdependent, and you can provide all the information in one file, and the Compose launches all these Dockers for you. So in this Docker file, it is quite simple, very self-explanatory. I'm starting 3 Consul servers, and I'm also starting 1 Consul agent. So as a best practice, you always talk to the Consul agent from an API or from whatever, you always talk to the Consul agent because you don't want to put a lot of load on the Consul servers and you don't want to do that. So leave the servers alone, always connect to the agent. It is one of the best practices you have to always follow. So you have the servers here and you have the client here. So let's start up. I'll try to, I hope you can see my screen. So I'm in that demo, I'm just doing a Docker compose up -d. So let's wait for Ready to work, yeah. And while this happens, yeah, the Dockers are coming up. Let's see, we have to wait for the Dockers to come up. During that process, I'll explain what is happening here. So for the initial cluster setup and for the leader direction, we always bootstrap one of the Consul servers as in here. And since we have 3 servers, we always have the bootstrap expect as the number of servers in the pool, which is 3. And I'm saying like, I want a UI interface and I want it to listen on 0.0 so that I don't mess up with the local host and all those stuff. And let's see. Yeah, so this means we have a new leader, the leader election is done, and the cluster of leadership acquired. So the Consul cluster should be up now. And before I start showing the UI and all those stuff, I want to understand, I want you to understand that Consul can be set up in a lot of ways. So this is one of the ways, like using Docker and Docker Compose. You can start Consul from a binary with command line tools, and you can start Consul using systemd. You can do a lot of things with the Consul binary as you like. So I always like to keep it in Docker so that I don't have to mess it around when I move to a different system or all those things. And it is easier. And let's see. So I hope Consul UI should be up. Yes, the UI is up and you can see 3 Consul servers and all are healthy. And these are the Docker IDs or the IDs of the Docker. And if I go to nodes, you can see 4 nodes, which means 3 server nodes and 1 agent node. And the star here means this is the current leader. So we have a leader, we have 2 followers and 1 agent. So let's try an example of how we can see some service discovery done by Consul. So I want to keep things simple and let's use a different. Yeah, so to show this example, I want to rely on my all-time trusted proxy, HA proxy. So I hope everybody is familiar with HA proxy. It is like the easiest tool you can configure to proxy. So I have a HA proxy Docker already ready. So I'll try to start that. Since I wanted the Consul to be up first, I didn't add the HA proxy Docker to the compose file. So let's go to the HA proxy configurations I have. So to make it very simple, I'll just show how a normal HA proxy configuration would look like. Well, I'll use my editor. It looks better, I guess, here. So this is how a normal HA proxy configuration would look like. Sorry. And you can see I'm saying, this is my front end, and I want the HA proxy service to be binded at port 80. And any requests coming to port 80, I want it to be forwarded to my default backend, which is app1 here. And I have given the configuration for the backend app1, and this is how you usually give the backend the information of which the service should be. So classically, you will do something like server, this is my app name, and this is the IP and port in which the application is running. So when HA proxy start, what it usually does it, any request, if it comes to port 80, it will just send the request to that IP and port. And if you have multiple replicas, you will do something like this, and it will be doing a round robin or whatever balancing policy you ask HA proxy to do. So this is what we want to avoid. We don't want to keep a static configuration, or we don't want to manually tell HA proxy like these are the servers you have to connect to. So what we have done is we have using one second. We are using templating, which is provided by Consul, a templating language, which helps us to leverage the Consul template binary and fetch values from the Consul server. I'll explain more about the Consul template in a minute. So this is how we give or manipulate the configuration file for HAProxy to find out the services with the help of Consul, like where it is running, which port it is running, and all those things. So instead of hard coding that IPs, we use a templating language. And with the help of Consul template. So this is another binary. So this is something different from the Consul binary, which we use to start the server and the agents. So there is another binary provided by Consul, which is called the Consul template, which actually helps us to fetch values from the Consul servers and feed it into our configuration. It is like, say, we don't have to write an application to fetch a value from somewhere and add it to our configuration. So Consul provides some help with the Consul template. It goes to the interface of Consul servers through the agent and gets the values of whatever you need, and it feeds into your configuration. And if needed, it will help you restart the application also. So this is how we changed a normal configuration where you have service IP and port, all those stuff, into a templating configuration. And this is what you tell the Consul template to do. So in my Docker file, I'm asking the Docker build step to copy the template into the Docker. And I'm copying it to this location. So this TMFL file is copied to etc consul template.haproxy.tmpl. And I'm telling, after you fetch the values from Consul and after you feed it to my configuration, I want the configuration to be I hope everybody can hear me. Sorry guys, I'm in Bangalore. The power problem is something to look out for. It will come back in some time, but let's see. So I'm telling Consul template, like this is my source file and I want this to be in this destination. And once that is done, I want you to execute this script when something changes in my configuration. And the haproxy.sh is a simple script which says the command to start haproxy or reload haproxy in case there is any change. So let's go ahead and build a Docker image. So let's fetch my Docker name from here. And I want to check something. Yeah, let's go ahead and build a Docker. So my Docker is built. I've already added the definitions to my Docker Compose. I'll just save it. If I didn't, I'll go to my directory and I'll do Docker Compose up -d again. And now my HA proxy should be coming up. I hope there is no errors. And yeah, it is up. So let's log into HA proxy. And let me check. Yeah, everything is running fine. So this is our configuration file. And see, so we don't have any server here. Nothing is here because we didn't start any application or we didn't register any application with the service. So that is empty. So let's do one thing. We'll add this to a counter and we'll keep on watching this terminal. So let me go ahead and let me start a Hello World application. I have a simple app here. So this is just a Python app which starts a Hello App server. So I'll just save that. And I'll just do Docker compose up -d again for my Hello World app to come up. Yeah, so the app is app, and from my configuration, I can see it is running in 8,000. So let's go ahead and see that. Localhost 8,000. Yeah. So if you can't see, we have a Hello World application running. And our HA proxy is running in 80. And since we have not registered the service with Consul and HA proxy doesn't have any information about this application, this should give you a 503, quite obviously. And now the process, we are going to tell Consul that we have an application ready to be registered, and we can register application in different ways. It depends on the use case, how you want to design your architecture. So we can always use the API endpoint, and with a curl request, you can tell Consul that you have an app with the name app1 running in this address at port 8000, and this is the health check you want to perform on that app. I'm just doing a TCP health check on my IP and port. So to anybody who is wondering, this is the IP which my laptop is connected to. And since I didn't want to make any trouble, I went with the IP. And this is the port in which the application is running. This again is the service ID, same as the name. And I want to perform a health check at every 2 seconds, and the timeout for the health check to go down or to fail will be 10 seconds. So you can also register Consul using the Consul binary and the command lines, or you can have that definition as part of JSON, and you can use the Consul command to call the JSON and register. So this is the easiest way I usually do. I'll include this with the Docker startup script of application, so it is registered when the application starts. So let's go ahead and execute the curl call. And let's see. So here, as soon as we register the application, the service definition or the backend information is available at HA proxy. So that was pretty fast. I'll do it once more. And if I do this, now the HA proxy port 80 is actually proxying us to the Hello World app container. So I'll just show it once more. So we have the Dockers running here. Let's go ahead and do something. We'll just remove this Hello World application. I'm just removing it, and let's see what happens here. Now, since the health check failed, Consul template actually watches that from the Consul servers, and once the health check is failed, the Consul template actually removes the values from the backend and it reloads HA proxy. So now we don't have any servers behind our HA proxy backend. So let's go ahead and do Docker compose up minus D once more. And let's see, once our application comes up, the backend service should hopefully come up. Yes. So now our Python app should work again. Yeah. So this is a simple demo on how service discovery works. And if your applications were running in multiple servers or multiple EC2 machines, this registration can happen with a different IP rather than the IP I configured in my curl request, because I have one replica, because I can't have multiple application running in the same port in my mission. So if you had different replicas, all those will be coming under the backend session, and the request would have been routed in a round robin fashion. So that's it. Now this is something I wanted to show you from a DNS perspective. So I told you about the API interface and also the DNS interface. So once a service is registered with Consul, Consul gives us the API feature which we just used, and also the DNS feature. So let's do something. So as I said, the DNS interface is running at 8,600. So let's do something, and we'll take a dig example. And let's see, by default, it should be, so we registered app1. Let's see if there is any, yeah, it works. So in the answer section, you can say the error code is pointing to the IP which I registered. So if I had, say, a DNS mask or something like that configured in my local machine, and I would have used the resolver to point to the Consul IP and port, or the server and port, then I could have pinged this DNS and I could have got the IP. So since I'm lazy and I didn't want to go that much further, I went ahead with a dig query to DNS interface directly, and you can see it working pretty well, I guess. I never tried it and it looks good. Okay, and let's go back to the Consul interface. So this is, and if I go to services, you can see the app one, and this is the node ID, this is the address in which it is working on, and both the node check and the service check is a success. So let's go back to my slide, and our demo for the service discovery part is done. So let's see the next thing. So the best feature about Consul. So this is something I, as a DevOps engineer, have leveraged a lot. For like so many use cases, I tried the key value pairs, and it always gave me a solution. So Consul also provides a key value. So it is self-explanatory, like Redis, all those things. You define a key and you set the value for that, and Consul saves it. And you have a 512 KB limit on these keys, I guess, because Consul don't want it to be used like a traditional database like Redis or something. So this is limited. I don't know whether there is any feature request going on to increase it, but I think I'm positive it is not happening. So the next thing is, as I said, the use cases provided by this feature is endless. I'll show some demos of some practical use cases of these key value stores. And from top of my mind, I can say like 2 or 3 use cases where I use this feature. So one is, as I said in the introduction part, when you want to run your application in different environments, test, staging, prod. So you can keep all these endpoints, say Kafka.com or test.kafka.com, prod.kafka, inside these YAML files and keep that key files in Consul. And when application starts up, you can provide like a profile in case of Spring Boot application or something like that to say, give a prod value, or you can use a simple global variable in your Docker startup script to see if you pass an environmental variable as test, then you load the test configuration. If you pass it as prod, you load the prod configuration. So what happens then is the application fetches the values from the Consul key value store as per the environment it runs on. So you can keep your Docker, like a singular Docker running in, not single, I would say same code base running in 3 different environments without messing around with the endpoints and configuration files and all those things. So this is something I use key values store for. And then there are like very low level use cases, like say if you're in the e-commerce industry, so you have coupon codes whose values changes rapidly or multiple times a day, and you don't want your application to be restarted every time to fetch a new value of a coupon. You can use these G2 consoles and console batches, all those things to fetch and load values dynamically into your application from a key store. So if your coupon gave a 50% off, and in the middle of the day, the business teams will know it is just 30%, you can just change the value in the key store and the application should be able to fetch that value, and the further request would be processed with that value. So I'm not going into the coding part, you have to talk with the dev, but people usually use that. I have used it. Then say you want to store your passwords, your usernames, you can encrypt it, keep it in the key value store, fetch it by the application, and if the application has the key to say KMS or something like that, it can decode the passwords and start using it. And since all these application uses these features of Consul a lot, I started using these in our infrastructure components as well. Say a configuration for Redis or a configuration for HA proxy. I don't want somebody to go in, change the configuration file, restart the application, either manually or either using something like Ansible, because it goes out of hand, and I don't want that to happen. And having everything at one place rather than in multiple configuration file is always the good thing. So if you have like 3 HA proxies running in your infrastructure and every configuration file is managed differently, it has different values and all those things. Imagine all the standard values, you keep it in an external storage and the application fetching it when they start up. It is quite beautiful, and that's the way to go. So that is one use case we can use key value store for. And as the service discovery, you can use the API request to post a key or get a key, and also you can use the Consul binary itself to get or put your key in. And Consul offers a UI for the key value store also, which I'll be showing you in a couple of minutes during the demo. And that's it regarding the key value store. And let's go to a quick demo, and I hope everybody will understand what happens here. So if you go to the Consul endpoint, we have the Consul key value store here. And right now there are no keys, and let's try something. So since I don't want to mess too many things up, I'll just use a couple of things in my demo. So one, the same HA proxy which I started, and also a Spring Boot app to show a different use case. So say we have the HA proxy template file here, and say we have 3 or 4 HA proxies running in an environment, and you always wanted the, say an example, the max connection value to be same in all the HA proxies, or you want this value to be configurable. You didn't want to go into every HA proxy and change the configuration, restart it either with Ansible, Puppet, or anything. So let's see how we can dynamically make Consul template fetch these values in and restart the HA proxy for you. Say, let's do one thing. So I'll make this value into a template. So I have an example here. So this is something I kept. I'll go to the template file. I'll replace this value with the key value. And I'll save that file. And since I changed that file, I have to build my Docker again so that the new file is picked up. And now we have to create the key, right? So this was the key we created in the configuration. So we'll create one key here. You can use the command line interface or the API interface. I'm using the UI to fetch in the API. So let's give a value like 2000. And I'll just save the key. So my key is now successfully saved. And since my Docker is built, I have to do a Docker compose again because there is a new image now. I hope the compose picks up the newer image. Let's see. So yeah, it is pre-creating the HA proxy. So let's wait for that to be done. Okay, that's done. I can see HA proxy was restarted. Now let's log into that HA proxy container. And yeah, HA proxy is running perfectly. And let's look at the configuration. Yes, so the value I put in has come. So let's see how we can dynamically change it. So I'll set a counter on this. So this is the key value which the Consul template is fetching from Consul. Say, I'll just go ahead and I'll do something like, I'll edit this value, maybe make it 3000. I'll just save it and let's see. Yeah. Now you can see that value has been updated to 3000. So you can do this with anything. You can make the timeout as a key. You can make maybe the port as a key. Anything in the configuration file that is prone to a change can be made into a key. So, and since it looks cool, I think I'll have to do that once more. Let's see. Yeah, it worked. So that's it. Now let's see another example. And this is an example from an application point of view where you can pass in YML files and you can have different stages in your application to load a different YAML file when you provide a different profile when it starts up. So I have a Spring Boot application here, which I hope will work. So we have to create a key for that in the beginning. So let's go ahead and create a key. So this is the keys it is expecting. So I'll create the key and the value for this will be like, I'll give something like a port broad string. So this is something we want to load in production. So I'll just save that key. That key is now saved in this YAML file. And let me try and start this application. I hope it starts because of the Java versions and all those things involved. So this is what I told about. So this is a profile which you can pass in the Java start command, like pro dev or something, and your application changing as per the YAML file changes. So I'll just try starting the application and hope it starts. It takes like 30-40 seconds to boot up, and I hope it boots up. Let's wait. And when I load this application in the browser, it should fetch the values from the key value store, and it should show me that. So this is an example of how you can manipulate the key value store. It could have been anything. Instead of the key value I gave, it could have been an endpoint to Kafka. It could have been an endpoint to Redis. It could have been an endpoint to MySQL or anything. So let's see whether I have configured it to run in 8080. Yes. I hope you can still see my screen, and yeah, that is how it fetches the value. And let's go back to the slide. This was regarding the demo, and that's my one-on-one on the service discovery part and also the key value store. Now, the next thing I want to talk about are some of the best practices I would do on a practical system, not like something which we could understand when you set it up, when you run it for multiple years, like number of years, you will understand things you have to do during a setup of Consul. So these are some of the best practices you should always go through. So always have a pool of Consul servers, not like have one Consul server managing a lot of clients. Always have a quorum requirement, and quorum of 1 or 2 is sufficient. So 3 or more servers in the odd range, like you know how quorum works, n minus 1 by 2. So if you have 3 servers, it is 1 quorum, and 5, it is 2 quorums. So always have at least a quorum of servers so that you are fault tolerant, you don't mess it up when there is a problem. And always make sure your data directory. So when you configure Consul, when you do the Consul commands in the command CLI, you can always configure the data directory where to keep the data we provide Consul. So always make sure that it is in a persistent volume, and mostly when you are using Docker. So I have seen people simply starting Consul Dockers in environments and they just leave it alone. They think like it is fine, because most of the time what they forget is to mount the volume to some persistent storage, and when there is an outage, you lose your data. And I'm not talking about one node failure, because since we have 3 clusters, 3 nodes in a cluster or 5 nodes in a cluster, the data will always replicate if it is one node failure. But imagine the whole DC going down. So always make sure your data directory is mounted and you're using stateful Dockers when you are in Kubernetes and all those things. And always remember one thing: when you configure Consul, use the gossip key. The gossip key is something like an authentication. So you start a set of servers, you provide the gossip key there, and you start a set of agent servers, you provide the gossip key there. So this is to identify that it is like a power of attorney. So if I have the key, then I can be part of that cluster. So this has happened to me. I didn't read about this thing, and I had multiple clusters running in one network, and if the IPs are routable, so what happens is if we don't have this password or key, what happens is these clusters during the LAN gossiping, it starts to combine as one and start sharing data. And that is the use case where we have multiple DCs, and it uses the WAN gossip to do that. And sometimes it can be not intended. Say when a couple of Consul clusters are handling different data, and they combine and start replicating between each other, what happens, they start to share the data, and this can mess up your application. So always make sure that if you want a cluster to be talking to just the components within the cluster, the server components and the agent components, you always use the Consul gossip key so that you're authenticated well. And not in all the cases, and I would suggest you use it always. That if you're handling sensitive data like passwords or what do you say, licenses of third-party softwares, then always use SSL TLS communication between the apps and Consul, and Consul gives us the feature to add certificates for secure communication. And so make sure if you're handling sensitive data, even though if your Consul cluster and agents and applications are running within a private VPC, it is an added security you can add from filtrators that you should always use SSL TLS communication. For my demo, I have not used it because I don't want to go with all those mess and make it more complex. So please do use it. And the other thing I want to talk about is mostly people nowadays, most of them use Kubernetes and all those orchestrators. And since I've been an user of Kubernetes, I found the Helm packages helping setting up these Consul servers really quickly and really easily. This is an extra help if people are interested. It is just a one command, and you can always reconfigure the values, but just one command, you start a pool of Consul servers and the agents running in every missions as a daemon set. So that is something I would advise people using if you are in Kubernetes and want to use the leverage of all these features provided by Consul. And within this scope of the demo and the one-on-one, I hope the service discovery and key value store will act as a good start for anybody to getting started with the features of Consul. Consul launched something like Consul Connect, where whatever the HA proxy did, most of this is now available with Consul. Also, you can use Consul Connect. The sidecar feature, which Consul gives to have a proxy running along with your application in Kubernetes, the service mesh feature, all those things, which we can cover in a later session. And when, if people are interested, if whatever I did today was good, then we can do this again and I could explain about it more. So these are the best practices which I usually follow. There are a lot more, and I don't want to go much into it. And yeah, so that's the end of the session from me, and we can do some question and answers if anybody has some question and I know the answers to that. I think we are quite early. We have 30 minutes left, and yeah, let's see.
Yes, Vishnu, there are a few questions. Let me read them to you. So there's one question about uh, can I do something like get a host name which is incremented? So example, there's one host name which is node 01, and can the next host name be node 02? Does it make sense? I think it would.
I didn't get the question actually. I didn't.
Yeah, I think it would be better if you could see the YouTube live stream directly from there.
One second. Let me do that. 1 second.
Vishnu, I pasted in the chat. Can you check the chat? You can stop sharing the screen if you want to.
Yeah, I'll do that. Yeah. Now let me. I'll go to YouTube and I'll just see that. Ablash, my screen is off, right?
Yeah, it is.
Okay. So let me go to the YouTube channel. Yeah, let's see some questions.
So it's towards the bottom.
Can I do something like get a host name? It is then incremented, so the next value is 1. You can not with a Consul feature, but you can always use a custom script to do that. And I wouldn't go much further into that. It should be done from the application and not from a script. It is like, say you store something somewhere and you fetch it. So if you want to add something to it, you should make the application or a script to it.
The next thing is, so when node count reduced by the quorum, won't it result in a split brain?
Yeah, I'm looking for that question. Yeah, if you don't have a column, like if you just have two servers, then it would definitely end up in a split brain. So you should. That is why I always tell in the best practices you should always have a column. So there is a really good example about that when you read about Raft algorithm. So you can just Google about Raft algorithm, and there is a good representation in the first link which pops up in Google. So I would encourage everybody to go through that to understand how the internals works. Yeah, let me go through the questions.
I think those were it.
Yeah.
There's one. Oh yeah, they are asking it now.
Yeah, from a curious techie, right? So the answer to that is it depends. Like you have service discovery provided by Kubernetes by default, but you can always use the key value store feature to dynamically load in configuration. So you can use the inbuilt DNS service discovery from Kubernetes using the kubedns, all those stuff, or you can use Consul. It depends on the advantage you see with it. Say, I have run into issues with using Kubernetes DNS. It had a lot of problems in the beginning when I started using it. There were some problems with least connections and all those problems which the IP tables inherited in the packages. So 5 seconds delays in DNS queries, all those things were there in the beginning, which led me to use some Consul service discovery in some of my cluster. And once the DNS, kubedns evolved into core DNS and all those things got fixed, I switched back to the service discovery, which Kubernetes provides by default. So yeah, so it depends on the architecture you provide. You can use anything which suits your use case.
It also depends on the workloads. If you have VMs running, then Consul can directly connect your VMs to the Kubernetes cluster. And I've seen scenarios where you have a common service registry, and Consul can pick up from core DNS, which Kubernetes uses, and register it on its own service registry.
Yeah, sure. Because the possibilities are endless. You just have to design it in such a way that it best suits you.
Yeah.
So I have the same question. You added a health check API for that 0.5 API. How can we do that dynamic? So I'll just say an example. Say instead of providing that IP, you can just say if you are registering a service from different host mission. I'm talking about when it is not in a cluster or something. You have 10 missions and you have 10 IPs for that mission, and you have added that curl request to the startup script of your Docker. So instead of having the hard-coded IP, you can just always fetch the IP from an environmental variable you provide. Maybe in your base mission, you can
I think we lost him again.
Yeah.
Let's wait for a minute.
We'll be back shortly.
You guys can still ask questions. I think he'll be back soon. Hopefully. Meanwhile, you guys can answer the feedback. We would really appreciate it because we can plan our sessions accordingly.
sorry guys, the power failure again. So answering to Arunlal, so say you have 10 missions, you can always pass the IP of the mission as an environmental
Vishnu,
variable.
your audio is.
It is not clear?
Yeah, we can hear you now.
Okay, so you can pass in that IP of the mission with a variable or something. And with the HCL files, which Consul provides, you can always do that dynamically when an application starts up fetching IPs from whatever servers they are running. And I can always give examples. You just do a $host IP and set the host IP variable in your mission. Or if it is Kubernetes, you have definitions where you can fetch the IPs of permissions. I hope it answers the question, but you can always get back to me. In case of a Consul cluster crash, and suppose we have only one active node, will it be possible to require a new node instead of the failed one? Yeah, you can use the retry join option and point it to the one which is running, and I hope it should be able to process with the gossip algorithm. It should work. I've not tried it. Maybe I never ran into an issue, or I was able to start the old node itself, but it should be possible.
Vishnu, I'd personally like to have a series on Consul and Kubernetes. So
Yeah,
I would
definitely.
really appreciate it. Yeah.
Yeah, definitely. We can have using the leverages of the key value store and also the service discovery. If you want to use that, we can have that.
Yeah, service mesh series with Consul Connect and stuff like that.
Yeah, we can have that. I didn't want that to be a part of the one-on-one, so I didn't
I get that.
want to mess up the session with too much stuff. So we can do that when we do a deep dive or something later.
Nice.
But I hope whatever I presented was clear, and it was easy for beginners and people to understand. I hope it was clear to you.
Yeah, it was a great session.
Yes, it was. It was awesome. You actually maybe worked quite a lot of things. So it was good. So I assume we don't have much of a question at this moment. It's all answered right now. So Harsh, shall we wind up?
Yeah, we can wind up.
Yeah. Can you have any final words?
I would like to thank both the speakers, Kerim and Vishnu. Thanks for your time.
Yeah, no
It was my
problem.
pleasure.
Yeah, thanks, Kerim. Also, Kerim, it was a really good session.
Thank you.
Yeah.
So yeah, so we'll catch up for the next meetup.
Yeah, sure.
See you guys. Yeah. Bye.
Thank you.
Okay, bye, guys. Everybody who was part of the session, thank you, and thank you for all the questions. I hope I answered it correctly. Yeah, thank you.
Thank you all, and
Bye.
see you on our next live stream.
Yeah, bye, guys.
Bye.
All right.